Langchain Robocorp Toolkits. Description: explain in detail. The Langchain Robocorp Toolkits provide a powerful combination of Langchain's natural language processing (NLP) capabilities with Robocorp automation platform. This integration empowers users to automate tasks that involve interacting with complex data sources, such as websites, databases, or APIs, using natural language commands. Inputs. Input 1. Explain in detail natural language instructions. The toolkits accept natural language instructions as input, allowing users to describe their desired actions in a human-readable format. For example, a user might input retrieve the latest news headlines from the BBC website. Input 2. Explain in detail data sources. The toolkits can be configured to access a wide range of data sources, including websites, databases, APIs, and files. These data sources serve as the information repositories for the NLP tasks. Outputs. Output 1. Explain in detail processed data. The toolkits process the input data sources based on provided natural language instructions, extracting and manipulating the relevant information. Output 2. Explain in detail automated actions. The processed data can then be used to trigger automated actions in Robocorp, such as sending emails, updating spreadsheets, or interacting with other applications. Steps. Step 1. Explain in detail natural language processing. The input instructions are passed and analyzed using Langchain's NLP models. These models understand the user's intent and identify the relevant entities and relationships within the instructions. Step 2. Explain in detail data retrieval and manipulation based on the NLP analysis. The toolkits retrieve data from the specified sources. This data is then manipulated and processed according to the user's instructions. Step 3. Explain in detail action execution. The processed data is used to trigger automated actions within Robocorp automation framework. These actions can be customized to perform specific tasks, such as updating a database or sending a notification. Metrics. Metric 1. Explain in detail accuracy. The toolkits can be evaluated based on the accuracy of their data processing and action execution. This metric assesses how well the toolkit correctly understands and executes user instructions. Metric 2. Explain in detail execution time. The time required for the toolkit to complete a task can be used as a metric to measure its efficiency. This metric helps to assess the toolkit's ability to handle tasks in a timely manner. Visualization plots. Visualization plot 1. Explain in detail data flow diagram. This plot visualizes the flow of data through the toolkit, highlighting the different steps involved in processing the input data and executing automated actions. Visualization plot 2. Explain in detail NLP model performance. This plot can display the performance of the NLP models used by the toolkit, such as the accuracy of entity recognition and intent classification. Fine-tune parameters. Parameter 1. Explain in detail NLP model selection. The user can select different NLP models based on their specific requirements and the complexity of the task. Parameter 2. Explain in detail data source configuration. The toolkits allow users to configure the connection to various data sources, specifying credentials and access permissions. Uncertainty methods. Uncertainty method 1. Explain in detail confidence score. NLP models can provide confidence scores for their predictions, indicating the level of certainty in their interpretation of the user's instructions. This can help users to identify potential errors or areas for improvement. Uncertainty method 2. Explain in detail ensemble methods. Combining multiple NLP models can reduce The impact of individual model errors. By aggregating the predictions of different models, the toolkits can improve the overall reliability of the results. Challenges and fixes. Challenge 1. Explain in detail ambiguous instructions. Natural language can be ambiguous, and users might provide instructions that are open to multiple interpretations. This can lead to incorrect data processing or action execution. Sample use case that resulted in challenge 1. A user instructs the toolkit to update the customer's address, but fails to specify which customer. Fixes to challenge 1. Prompt engineering. Design prompts that guide users to provide clearer and more specific instructions. For example, the prompt could ask for the customer's name or ID to ensure clarity. Contextualization. Leverage previous interactions or available context to resolve ambiguities. For example, if the user has previously referenced a specific customer, the toolkit can use that information to interpret the instruction. Challenge 2. Explain in detail data source errors. Data sources can contain errors or inconsistencies, leading to inaccurate data processing. Sample use case that resulted in challenge 2. A web page contains outdated information, resulting in the toolkit retrieving incorrect data. Fixes to challenge 2. Data validation. Implement data validation mechanisms to detect and handle errors in the retrieved data. This can involve checking for consistency, completeness, and other data quality metrics. Error handling. Design mechanisms to gracefully handle errors that occur during data retrieval or processing. This could involve logging the error, attempting to retrieve data from alternative sources, or notifying the user of the issue. Challenge 3. Explain in detail lack of flexibility. Traditional automation approaches often lack the flexibility to handle dynamic and unpredictable scenarios. This can limit the toolkit's ability to adapt to changing data or user requirements. Sample use case that resulted in challenge 3. The user wants to automate a task involving a specific website, but the website structure changes unexpectedly. Fixes to challenge 3. Adaptive learning. Implement mechanisms for the toolkit to learn and adapt to changes in data sources or user instructions. This could involve using machine learning algorithms to automatically update the toolkit's behavior based on new data. User feedback. Provide mechanisms for users to provide feedback on the toolkit's performance, allowing for continuous improvement and adaptation. This could involve rating the toolkit's accuracy or providing suggestions for improvement. Langchain Robocorp Toolkits Action Server Request Tool. Description: the Action Server Request Tool is a Langchain tool that allows you to interact with Robocorp Action Server. This tool can be used to execute workflows, retrieve data from tasks, and manage your Robocorp environment. Workflow: name the name of the workflow to be executed. Inputs: a dictionary containing the input parameters for the workflow. Response: the output of the workflow, which may include data, logs, or other information. Status: the status of the workflow execution, e.g., success, failed, running. The tool connects to the Robocorp Action Server. It sends a request to execute the specified workflow with the given input parameters. The tool retrieves and returns the response from the Action Server. Execution time: the time taken to execute the workflow. Resource usage: the amount of resources consumed during workflow execution, e.g., CPU, memory. Workflow execution graph: a visual representation of the workflow execution, showing the order of tasks and their dependencies. Data flow diagram: a diagram that shows the flow of data through the workflow. Timeout: the maximum time allowed for the workflow execution. Retries: the number of times to retry the workflow execution in case of failures. Confidence scores. The tool could provide confidence scores for the output based on the workflow. Execution. Error analysis. The tool could provide information about potential errors and their impact on pay. Workflow execution. Challenge 1. Workflow execution errors. A workflow execution failed due to a programming error or invalid input data. Review the workflow code and input data to identify and fix the error. Use logging and debugging tools to investigate the cause of the error. Challenge 2. Network connectivity issues. The tool was unable to connect to the action server due to network connectivity problems. Ensure that the network connection is stable and the action server is reachable. Use a proxy server if necessary to bypass firewall restrictions. Langchain Robocorp Toolkits Action Server Toolkit. Description. The Action Server Toolkit is a powerful tool that allows you to easily create and deploy Langchain agents to a Robocorp action server. This toolkit simplifies the process of integrating your Langchain agents into your existing automation workflows, enabling you to leverage the power of large language models within your Robocorp environment. Inputs. Langchain agent. This is the Langchain agent that you want to deploy to the action server. The agent can be a basic chain, a tool using agent, or a more complex agent architecture. Robocorp Action Server Configuration. This configuration defines the details of the action server, where the agent will be deployed. This includes the server's address, port, and authentication details. Outputs. Deployed Langchain agent. This is the successfully deployed Langchain agent on the Robocorp action server. Action server status. The toolkit provides information about the action server's status, including its current state and any relevant error messages. Steps. Define the Langchain agent. You begin by defining the Langchain agent that you want to deploy. This agent should be designed to handle the specific tasks or workflows you want to automate. Configure the Robocorp action server. Configure the action server's settings, such as its address, port, and authentication credentials. Deploy the agent. Utilize the toolkit's deployment functionality to upload the Langchain agent to the specified action server. Metrics. Deployment time. This metric tracks the time it takes to successfully deploy the agent to the action server. Agent execution time. The toolkit records the time it takes for the deployed agent to execute a task. Visualization plots. Agent execution time plot visualizes the distribution of execution times for the deployed agent, helping you identify potential performance bottlenecks. Fine-tune parameters. Action server timeout. This parameter allows you to adjust the maximum time allowed for an agent to execute a task on the action server. Setting an appropriate timeout prevents agents from becoming unresponsive. Logging level control. The level of logging information generated by the toolkit and the deployed agent. This can help you troubleshoot issues during development and deployment. Uncertainty methods. Confidence scoring. The toolkit can be used to integrate confidence scoring mechanisms into your Langchain agents. This allows you to assess the reliability of the agent's output and handle situations where the agent may be uncertain. Challenges and fixes. Challenge 1. Incorrect action server configuration. You may encounter issues if the action server configuration provided is invalid or incomplete. Sample use case that resulted in challenge 1. The user provides an incorrect port number for the action server, leading to a connection failure. Fixes to challenge 1. Verify that the provided action server configuration is accurate, including the server's address, port, and any required authentication details. Challenge 2. Agent execution errors during agent execution. The toolkit may encounter errors due to unexpected inputs or limitations in the agent's capabilities. Sample use case that resulted in challenge 2. The agent encounters a data format error when processing a specific input, leading to an exception. Fixes to challenge 2: review the agent's logic and ensure it can handle the expected inputs correctly. Add error handling mechanisms to gracefully manage unexpected data or errors. Langchain Robocorp Toolkits Run Details Callback Handler. Description: the Run Details Callback Handler is a class in the Langchain Robocorp Toolkits that provides a mechanism for logging and visualizing the execution details of a Langchain application running within a Robocorp environment. Run details: this input represents the detailed information about the execution of the Langchain application. It encapsulates data like the current step, progress, execution time, and any encountered errors or warnings. Context: this input provides access to the broader context surrounding the execution of a Langchain application. This could include information about the specific task being executed, the user's input, or any relevant environment variables. Execution log: a detailed log of the execution steps, progress, encountered errors, and warnings. Visualization data formatted for visualization, such as plots or charts that depict the execution progress, resource usage, or any relevant metrics. Initialization: the handler is initialized with the run details and context. Logging: the handler logs the run details to a designated log file or console output. This log can include information about the start time, current step, execution duration, and any errors or warnings encountered during the execution. Visualization: the handler processes the run details and context to generate visualization data. This data could be in the form of plots or charts that illustrate the execution progress, resource usage, or other relevant metrics. Execution time: the duration taken for each step or the entire execution. Resource usage: information about the CPU, memory, or other resources consumed during the execution. Step completion status: a record of which steps have completed successfully, failed, or are in progress. Execution timeline: a plot depicting the start and end times of each execution step. Resource usage plot: a chart showing the CPU, memory, or other resource consumption over time. Error distribution: a visualization that summarizes the types and frequency of errors encountered during execution. Log level: the level of detail to include in the logs, such as debug, info, warning, or error. Visualization type: the type of visualization to generate, such as line charts, bar charts, or scatter plots. Visualization frequency: the frequency at which the handler generates visualizations, such as every step, every minute, or at the end of execution. Not applicable. Challenge 1: handling large log files. Sample use case that resulted in challenge 1: running a Langchain application with extensive logging can lead to large log files that can consume significant disk space. Fixes to challenge 1: implement a mechanism to rotate or archive log files periodically to prevent excessive disk usage. Challenge 2: performance impact of visualization. Sample use case that resulted in challenge 2: generating visualizations during execution can introduce a performance overhead, particularly if the visualization process is computationally intensive. Fixes to challenge 2: optimize the visualization process to minimize performance impact. Consider generating visualizations asynchronously or only at specific intervals to avoid impacting execution speed. Langchain Robocorp Toolkits Tool ARGs. Description: the tool args class provides a mechanism to define and manage arguments for tools in the Langchain Robocorp integration. These arguments are used to configure and execute tools within your workflows. Inputs: tool name: the name of the tool that the arguments are associated with. This helps identify and organize tools within your workflow. Tool parameters: a dictionary of key value pairs that define the parameters required by the tool. Each key represents a parameter name, and its corresponding value specifies the parameter's type and default value. Outputs: tool output: the result of executing the tool with the provided arguments. The output format depends on the specific tool and its implementation. Steps: define tool arguments. The step involves creating an instance of tool args with the name of the tool and the required parameters. Pass arguments to tool. The defined arguments are then passed to the tool when it is invoked within the workflow. Tool execution: the tool processes the input arguments and performs its designated task, generating the output. Metrics: tool execution time: the duration taken to execute the tool with the provided arguments. Tool success rate: the percentage of successful executions of the tool based on the provided arguments. Visualization plots: tool parameter influence: a visualization plot showing how changes in different input parameters affect the tool's output. Tool output distribution: a visualization plot showcasing the distribution of output values obtained from the tool for various inputs. Fine-tune parameters: parameter optimization: fine-tuning the parameter values within the tool args to optimize tool performance and achieve the desired results. Parameter sensitivity analysis: analyzing the impact of small changes in parameter values on the tool's output. Uncertainty methods: input uncertainty propagation: estimating the uncertainty in the tool's output based on the uncertainty in the input parameters. Output uncertainty estimation: determining the confidence level in the tool's output based on the uncertainty inherent in the underlying data or model. Challenges and fixes: challenge 1: incorrect or missing tool parameters. Sample use case that resulted in challenge 1: attempting to execute a tool without providing all the required parameters or with incorrect parameter values. Fixes to challenge 1: ensure that all the necessary parameters are defined and provided with correct values in the tool args instance. Challenge 2: tool execution errors. Sample use case that resulted in challenge 2: errors occurring during the execution of the tool, such as network issues or unexpected input data. Fixes to challenge 2: implement error handling mechanisms within the tool implementation and handle potential errors gracefully. Challenge 3: inconsistent output format. Sample use case that resulted in challenge 3: the tool output format varies depending on the input parameters or other factors, making it difficult to process. Fixes to challenge 3: standardize the output format of the tool to ensure consistent data structure across different executions. Challenge 4: limited parameterization options. Sample use case that resulted in challenge 4: the tool args class may not support all the required parameters for the tool, leading to limitations in configuration. Fixes to challenge 4: extend the tool args class to accommodate additional parameters specific to the tool. Challenge 5: difficulty in visualization. Sample use case that resulted in challenge 5: challenges in visualizing the relationship between tool parameters and outputs. Fixes to challenge 5: explore different visualization techniques and tools to effectively represent the data and insights from the tool execution. Langchain Robocorp Toolkits Tool Input Schema. Description: the Tool Input Schema class provides a structured way to define the inputs, outputs, steps, and other relevant details for a tool in the context of Langchain and Robocorp toolkits. This schema is crucial for facilitating seamless integration and understanding between different components within these frameworks. Inputs. Input 1. This represents the data or information that the tool expects as input. It could be in various formats like text, files, URLs, or structured data like JSON or CSV. The specific input format should be clearly defined to ensure the tool receives and processes the input correctly. Input 2. Similar to input 1. This denotes another potential input required by the tool. There might be multiple inputs, each with its own specific data type and purpose. For example, a tool might take a text prompt as input 1 and a file path as input 2. Outputs. Output 1. This defines the expected output format and type generated by the tool. It could be a text response, a list of items, a modified file, or a data structure. Clearly specifying the output format helps downstream components understand and utilize the tool's results effectively. Output 2. Similar to output 1. This describes another potential output that the tool might produce. For instance, a tool might return both a textual response and a JSON object containing structured information. Steps. Step 1. This describes a specific action or operation performed by the tool as part of its execution process. Steps help break down the tool's functionality into manageable units, making it easier to understand and debug. For example, a step could involve retrieving data from a database, processing text using a language model, or generating a visualization. Step 2. Similar to Step 1. This outlines another key step involved in the tool's execution. Steps can be sequential or parallel, depending on the nature of the tool's functionality. Metrics. Metric 1. This defines a quantitative measure used to evaluate the performance or effectiveness of the tool. Metrics are essential for understanding the tool's capabilities and identifying potential areas for improvement. Common metrics include accuracy, precision, recall, execution time, and resource usage. Metric 2. Similar to metric 1. This represents another metric used to evaluate the tool's performance. The choice of metrics should be relevant to the tool's purpose and the desired outcomes. Visualization plots. Visualization plot 1. This refers to a visual representation of the tool's results or data. Visualization plots are highly beneficial for gaining insights and understanding complex information. They could include charts, graphs, heat maps, or other visual elements. Visualization plot 2. Similar to visualization plot 1. This denotes another potential visualization that can be generated by the tool. Visualization plots can be customized based on the specific requirements and data being presented. Fine-tune parameters. Parameter 1. This represents a parameter that can be adjusted to fine-tune the tool's behavior or performance. Fine-tuning parameters allow users to optimize the tool for specific use cases or improve its performance on particular tasks. Parameter 2. Similar to parameter 1. This denotes another parameter that can be adjusted for fine-tuning. Examples of fine-tuning parameters could include thresholds, learning rates, or model weights. Uncertainty methods. Uncertainty method 1. This refers to a method used to estimate or quantify the uncertainty associated with the tool's outputs. Uncertainty methods are crucial for understanding the reliability and trustworthiness of the tools. Predictions or recommendations. Common uncertainty methods include confidence intervals, probability distributions, or ensemble modeling. Uncertainty method 2 similar to uncertainty method 1. This represents another potential method for quantifying uncertainty. The choice of uncertainty method should be based on the specific nature of the tool and the desired level of uncertainty analysis. Challenges and fixes. Challenge 1. This describes a common challenge or issue encountered when using the tool. Identifying and addressing challenges helps improve the tool's usability and reliability. Sample use case that resulted in challenge 1. This provides a concrete example of how the challenge might manifest in practice. It helps users understand the specific scenarios where the challenge might arise. Fixes to challenge 1. This outlines solutions or strategies for addressing the challenge. Fixes could involve modifications to the tool's code, changes to input data, or adjustments to the tool's configuration. Challenge 2 similar to challenge 1. This describes another common challenge. Sample use case that resulted in challenge 2. This provides a concrete example of how the challenge might manifest in practice. Fixes to challenge 2. This outlines solutions or strategies for addressing the challenge.